paper. Scatterplots. Take a minute, read the objective and read this first paragraph right here. So scatterplot, you're gonna take and analyze real world data, just like number one from your worksheet. You've got McDonald's. You're studying fat grams versus calories. There's gonna be three types of correlation, relationship. The first one is a positive, which is what your number one is. Draw a picture. You've got dots. Each study is represented with a dot. So each menu item on that McDonald's menu is graphed with the dot. Now, why is this positive? Why would this one be positive? Because what we try to do is we try to write a linear equation. Write this down. Y equals mx plus b. So we want to analyze all of our data. We've got it all graphed. We want it to fit a linear pattern with your line of best fit. So your data right here, if you draw a line that cuts your data right in half, it's going to look something like that. That's called your line of best fit right there. Or it's kind of like the average. Some of your data is going to be above it, some of it's going to be below. But it's kind of like an average line. Now, you just look at the slope of it. If this has a positive slope, it's going to be a positive relationship. What that means is this. As x increases, y increases. So they both go up. So in this case, the more fat grams, the more calories. Austin, they're both going up. The more fat grams, the more calories. Let's look at a negative correlation. What would a negative correlation look like? Yeah, it would be opposite. If you had a coordinate plane and you did a study of your data and it looks something like this. So each dot represents a coordinate plane or a ordered pair, and if it's kind of tightly grouped together, that means there's going to be a relationship. And if you try and fit all of this data to a linear equation, try and put an average line in there, a line of best fit, it's going to look something like this. And if this has a negative slope, that means they are related, but they're negative. So they could be something like this. As x increases, what's happening to y? Y decreases. So one goes up, the other goes down. So what would be an example of this? A negative correlation. If you write this, write down the more I exercise, the skinnier I get. So what's happening, if I spend more time exercising, what's happening to my weight? It's going down. So the more that I exercise, the skinnier I get. One goes up, one goes down. What about a no correlation? Okay, no correlation is just totally random. So if we did a survey, if we did a study and we're trying to analyze some data, if you graphed your data and it looked like this, they're all over the place. You've got dots everywhere. There's no uniform pattern. That means that there's no relationship. It's just totally random. An example would be this. If we studied your hair color versus your height, there would be no relationship. Your hair color does not in any way influence how tall you are. So they would just be random dots all over the place. Okay, the very last thing you need to know is outlier. An outlier. So go to your positive or your negative, one of these, and let's put a dot that's way outside the rest of the pack. clear out here, way above or way below. That's an outlier. They're nowhere near the average or the rest of the numbers. If we did this, if we did a study of your parents' monthly income, so we took everybody in here and we got your parents' monthly income and we graphed it, and then we threw an outlier. An outlier would be like Michael Jordan. If we put Michael Jordan's monthly income, it would be way, 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 way above our parents. Our parents, for the most part, would be kind of in a tight group, but an outlier would be Michael Jordan or someone else that's famous and rich, because they would not even be in the same ballpark as us. So here's what you need to do. For your number one, you have dots for McDonald's menu items, fat grams versus calories. I need you to take the lid off your calculator. We're going to use it as a ruler. You need to zero in on 2 of these dots. You need 2 dots. Just 2. Now look, I'm not going to choose this one and this one. Here's how you use your lid. Let me see that. So if I put the lid on here and use it kind of as a straight edge and I connect these 2 dots, is that a good average line? No. You want to choose 2 dots that are going maybe like this guy and this guy. If I connect these 2, that is much better. Half of my data is above it, half of my data is below it. Why don't you give them to me? What 2 did you choose? 12 and 360? 21 and 440? So 12 and 360, that is the, what is that?
Maybe it's
13 and 320. Alright, let me erase it. 13 and 320. So you got 13 and 320. So that one is, that's your cheeseburger. And then 21 and 440, what ones that match up with? Oh, 21 and 420? Okay, now, your dots are going to be different than Katie's. You chose different dots. You got different eyeballs than her. They're going to be close, though. You need to calculate 2 things. What do you need to calculate? M and B. Because we want to know the formula of this equation. We want to know the slope-intercept form y equals mx plus b. So Katie, your m is going to be this. I would do 420 y minus y, 320, divided by x minus x. So you guys calculate your own slopes and find out what the m is. And then choose one of your 2 points, plug in an x and a y and an m, and calculate your b.